Today we're going to talk about common atmospheric pollutants. Okay, so atmospheric means in the atmosphere. So not things like plastic, which we could say is a pollutant, but things that are in the atmosphere. So generally different gases, maybe some very small particles, and there are 7 of them that we're going to talk about. We're going to talk about the way they are formed, the problems they cause, and how the problem could be reduced. So each of this is going to be a little mind map that we're going to do together. Each of the branches is going to have kind of 3 sections to it. So where does it come from? How is it formed? And why or how can we reduce it? So I would like you to draw in the middle of your page a little bubble with common atmospheric pollutants in the middle of it. So I'm just going to zoom out a little bit so we've got a bit of space. By far the most common atmospheric pollutant, or the one that we're most interested in and we'll talk about the most often, is, I'm going to draw a little arrow up there, is carbon dioxide. Okay, so where does carbon dioxide come from? Well, carbon dioxide comes from burning fuels. So it comes from what we call combustion. So it comes from combustion of fuels. That could be in your car, that could be for power, it could be for lots of different reasons. And really it's talking about complete combustion. So complete combustion of fuels. There's a different type of combustion that we'll talk about in another lesson, but this comes from the complete combustion of fuels. Now, why are we concerned? Why do we class it as a pollutant? Why are we concerned about carbon dioxide? Well, carbon dioxide, as we've talked about in the previous lesson, is a greenhouse gas. Okay, and you can go back to that previous lesson to check what a greenhouse gas is, but essentially it's thought to be causing global warming and climate change. How do we go about reducing the amount of carbon dioxide in our atmosphere? Well, we need to reduce the use of fossil fuels. If we can reduce the use of fossil fuels and change them for other types of fuel and energy, be much less carbon dioxide being released into the atmosphere. On each of these arrows, let's just write what this is. So this is how it's formed on the top arrow. So carbon dioxide is formed by complete combustion. It's the problem with carbon dioxide, I'll make this arrow a little bit bigger next time. The problem with carbon dioxide is it's a greenhouse gas. And how do we reduce the carbon dioxide? We reduce the carbon dioxide by reducing the use of fossil fuels and using alternative energy sources, and maybe even increasing the efficiency. So if we do use fossil fuels, we use less of them. So that is carbon dioxide. That's our first pollutant, and how it's formed and the problems and how we reduce it. So that's our most important one, I think, the one that we spend the most time thinking about. So make sure, if you haven't already, pause it here and make sure you've got all that written down, because you're going to need to use that in a moment. If you have got that written down, I'm just going to zoom out a tiny bit and come down a little bit, just cut off the top of that, because we're going to go on to our next pollutant. It's got a very similar name, but it is not the exact same. So this one is carbon monoxide. So carbon monoxide. So rather than dioxide, this is monoxide. It means it's only got the one oxygen. So if we were to write out the formula, this is capital C, capital O. I'll put that in brackets just underneath. And up here we could put carbon dioxide as capital C, capital O, and then a subscript 2. So CO2 is what we would talk for carbon dioxide. This is carbon monoxide. So most fuels contain carbon, and when they burn, if there's plenty of oxygen, they form carbon dioxide. If there is not enough oxygen, then we get carbon monoxide, and we call that process incomplete combustion. So it is like carbon dioxide, but there's less oxygen about. There's not enough oxygen there, so in fact the carbon can't get 2 oxygens each, so they only get 1 each, and then you have incomplete combustion of fuels. So that's how it's formed. Okay, so it's formed by incomplete combustion. And again, we'll talk a little bit more about combustion in a different lesson. Why is carbon monoxide a problem, or what is the issue with carbon monoxide? Well, carbon monoxide is toxic. So it's a odorless, which means it doesn't smell, colourless, which means you can't see it, gas, which is toxic. The way it does it, or the reason it's toxic, is because it combines with new hemoglobin in your blood and reduces the ability of the blood to carry oxygen around your body. Not necessarily an issue for the planet and global warming or global climate change as such, but definitely an issue for human beings. You don't want to be around lots of carbon monoxide. How could the problem be reduced? Well, to reduce the problem, to reduce the amount of carbon monoxide being produced, it's quite simple, this one. You have to make sure, or ensure, which means make sure, ensure there is a good supply of oxygen. So when you're burning something, make sure it's not an enclosed space. Make sure there is a good supply of oxygen. I'm just going to move this down so you can see a little bit more clearly. Make sure there's a good supply of oxygen to provide the oxygen for it to have complete combustion, which makes carbon dioxide still an issue. Carbon dioxide we know is an issue as well, but it's much safer than carbon monoxide in the short term. Ideally, we don't want the carbon dioxide either, but for now, we'll accept carbon dioxide as an alternative to carbon monoxide. Still sticking with carbon, and again, if you are waiting, if you haven't written that down yet, take the time to pause this now and write that down. And that might be the best way to do it, actually listen and then pause and then write down. If you have written it down, then we're going to go on to the next one. And the next one we are going to go on to, the next arrow, and there's going to be 7 arrows in total for you to kind of plan how you're going to use your page. Your next arrow is going to be, I'm just going to zoom in down here a little bit. Your next arrow is going to be soot. Sometimes we just call it carbon particulates, which is another phrase, or particulates. A bit like particles, very small pieces of solid, for example. But soot in particular is a type of particulate, and we would just say that the formula for soot is C, because it's just carbon, capital C. So again, most fuels contain carbon, and again, if there isn't enough oxygen, if there's really not enough oxygen, then if there's not enough oxygen, you might get carbon monoxide. But if there's very little oxygen when you're burning a fuel, you need some for it to be able to combust. But if there's very small amount of oxygen, then what you end up with is some soot. Okay, so it's again formed by incomplete combustion of fuels. Why is soot, or why are particulates an issue? What problem do they cause? Well, the problem that soot or particulates cause is that they cause an issue called global dimming. And it's exactly what it sounds like. So if you've ever seen a dimmer switch in a house, a little kind of like dial normally, instead of a light switch, and you turn it down and the lights go dimmer, the lights go down, that's what's going on. So soot is being released into the atmosphere. That soot is kind of forming a layer, not necessarily a layer, but it's kind of getting into the atmosphere with these particles, these dark black particles in the atmosphere of soot. And when they are in the atmosphere, they stop the sunlight reaching Earth. So global dimming is reducing sunlight reaching the surface. So obviously it reaches Earth's atmosphere, but it reduces the amount of sunlight, making it all the way through the atmosphere to the surface. And obviously we don't want to live in a world where it's dark all the time, or it's dimmer than it is now, because of the amount of soot in the atmosphere. What do we do to reduce it? Well, actually it's the same answer we had for reducing the amount of carbon monoxide. So to reduce the problem, all we need to do is we need to make sure is how I like to think about ensure, there is a good supply of oxygen. If you ensure there's a good supply of oxygen, you'll get less soot produced. Now we're about nearly halfway through. We've got another 4 to go. So make sure at this point, pause it, write down soot, and just make sure you double check that you've got all of this information around your bubble, because you're going to need it all for when we do some questions after writing this down. So what else do we have? So I'm going to zoom back in. Oh, sorry, actually, let me just leave it there for a second. If you want to pause it now, and then I'm going to move on to the next one. So if you want to pause now, write them down, and that's enough time. So we're going to look at the next one. So we're halfway through, remember, nearly. We will be by the time we've done this. The next kind of common pollutant that I want to think about doesn't necessarily cause a huge amount of problems, but is something that's produced when we burn fuels and is common in our atmosphere. So it's water vapour. So water vapour, we're not talking about liquid water, we're talking about water in the form of a gas. So let me write H2O, which we know is the formula for water, but let's make sure we're very clear that it's water vapour by putting brackets G, so that's the state symbol for a gas. So many fuels contain carbon, and most fuels also contain hydrogen. So that hydrogen, the H, when it reacts with the oxygen, forms water vapour on combustion. So how is it formed? It's formed during combustion of hydrocarbon fuels. Now, like I say, we talk about, and I've kind of done it for everyone, so I'm going to do it here, the problem with water vapour. There isn't a huge amount of problem with water vapour, and we know that the water cycle that you might have done means that water vapour is moving in and out of the atmosphere all the time, in the form of rain, in the form of water kind of evaporating off the surface and forming clouds and various things. So there is no major issue with water vapour as far as we are concerned. It's moving around a lot due to the water cycle. It doesn't necessarily build up and cause a huge issue. So actually, we don't need to worry about reducing it. So because there's no major issue, we don't need to worry. So we're not worried about reducing it because it doesn't really cause any major issues. So we're not going to worry about how we reduce the water vapour. It would be very hard to do. Water vapour is produced whenever you burn a fuel in any way, so it's part of the combustion. There is water vapour produced. So again, you can pause, double check you've got everything down, that it's looking good, and we're going to go on. We're over halfway now to do the last 3 of these. So the next one after water vapour is one that does cause a few issues, and the next one is sulfur dioxide. So sulfur, spelt with an F, sulfur dioxide. So sulfur dioxide, like carbon dioxide has 2 oxygens in it. Sulfur dioxide has 2 oxygens. So sulfur is the S, capital O for the oxygen, and 2 of them because it's dioxide. So what's sulfur dioxide? How is it formed? Well, sulfur dioxide is particularly formed when you burn things like coal, because they actually contain some impurities. So they're not pure, they're not just carbon and hydrogen and various other things. They often contain some impurities called sulfur, and when you combust, so there are impurities of sulfur in the fuel, and therefore when you combust the fuel, when you burn the fuel, then you produce sulfur dioxide along with carbon dioxide and water vapour. So you produce some sulfur dioxide. Sulfur dioxide is an issue for us. So what is the problem that it causes? Well, the problem caused by sulfur dioxide is acid rain. And there's a quite complicated equation to work out how it forms acid rain. But essentially, what you need to know is that when the sulfur dioxide it gets into the atmosphere, it mixes with water vapor. There's a reaction that happens. There's multiple steps in the reaction, but you're essentially forming very dilute sulfuric acid. Why is acid rain an issue? I'm just going to write it down over here because there's something else we're going to talk about in a minute. So acid rain is an issue because acid rain essentially means that it's raining a very dilute or very dilute acid. Why is that an issue? Well, it damages plants. So the acid on the plants damages the plants, damages stonework, and it can cause changes into pH in aquatic environments. So that means the pH changes in rivers or lakes. Not necessarily the sea, because the sea is very big, but particularly in kind of like smaller areas of water, like a small pond and things like that, it can change the pH. And if it changes the pH, the fish aren't evolved or designed to live in that kind of environment with a different pH. Perhaps even more worryingly for us, maybe not more worryingly, maybe those are things that we should really be worried about. But another reason why we as humans should be worried is it causes respiratory issues for humans. Now, respiratory refers to your respiratory system. That is you do this in biology, but your lungs and various parts of your body, and it's involved in your ability to breathe and then respire. So it's damaging your ability to breathe in that air that then is used for respiration in your body. So it is an issue for us, okay? And it's a not very nice issue. So we'll talk a little bit more about acid rain, and you'll have a little chance to write it down in a second. So why or how do we reduce the amount of sulfur dioxide formed? Because that seems like an important thing for us to do. So how do we reduce it? So it's hard to reduce it. So you can have fuels with more pure and don't contain sulfur, or you have to remove the sulfur dioxide from the waste gases. So you have to remove it from the gases before it gets in the atmosphere. So what you'd have is a system to do this built into kind of chimneys that you see on kind of power plants or whatever. So as the waste gases are produced and are rising into the atmosphere, there's a system there to remove the sulfur dioxide before it reaches the atmosphere. Make sure you take a minute to write it down. If I zoom out a little bit, hopefully you can see all of sulfur dioxide and acid rain. And you can pause the video and do that. Again, I'm going to keep going because I don't want the video to be too long. So similarly to sulfur dioxide, another chemical or another substance or product, an atmospheric pollutant that causes issues with acid rain is nitrogen oxides. There's different nitrogen oxides that cause this issue, and we'll talk about two of them in particular in chemistry. We talk about NO and we talk about NO2, so nitrogen monoxide, nitrogen dioxide, much like we have carbon dioxide and carbon monoxide. How are nitrogen oxides formed? Well, you should hopefully know that there's a lot of nitrogen in the atmosphere. In fact, the atmosphere is nearly 80% nitrogen. So nitrogen in the air, nitrogen in the air is able to react with oxygen. because nitrogen is very unreactive generally, but reacts with oxygen at high temperatures, and particularly very high temperatures when we're burning fuels. This actually happens in cars. So in the engine of cars, that's why they get very hot, and the nitrogen in the air can react with the oxygen to form nitrogen oxides. The problem it causes is acid rain. And again, we'll link that acid rain, much easier to link this time, over to here so that we can know why acid rain is an issue. And the way that we reduce the amount of nitrogen oxides that gets into the atmosphere. So there's the same process as a sulfur. We can remove it from the waste gases. You can also adjust the way the fuel is burned to reduce the amount produced. So if you can burn it at a lower temperature, or you can adjust the amount of nitrogen in the mix when it reacts. An interesting one. So I said that nitrogen oxides is produced in cars. So an interesting way that we reduce the amount of nitrogen oxide, making it into our atmosphere, is catalytic converters. So they are on your car. Your car probably has, or your parents' car probably has, a catalytic converter, which is kind of in line with the exhaust, and it takes the fumes and it helps to react with some of the nitrogen oxides to reduce it to something that's less dangerous to be released. You don't need to know much about that mechanism or how that happens. You do need to know more about it if you do A-level chemistry, and it is interesting how it works, but we're not going to go into any details now. So nitrogen oxides and sulfur dioxide, those are the things that cause acid rain, which is becoming more of an issue in recent years, particularly since since the Industrial Revolution, so maybe not super recent years. The final thing that gets released into the atmosphere when we're burning fuels, before we look at the whole thing together, the final thing that gets released into the atmosphere is unburned hydrocarbons. Now, unburnt hydrocarbons, essentially are, well, let's think about how they're formed, and then we'll think about what they really are. So how are they formed? They are formed when hydrocarbon fuels are burned. So something like petrol or diesel, that's a hydrocarbon. When those are burned, some molecules may not burn, and so some of them are released. So they get carried up in the convection various ways. But essentially, it's the molecules that haven't burnt during combustion, and they can end up in the atmosphere because they are able to become a gas. Some fuels are gases. It wastes fuel for one reason, so it reduces the efficiency. That's one of our problems with this. But it also, often, they are greenhouse gases. So there's two problems. Wastes fuel, because some of that fuel is just ending up in the atmosphere. And that's not great when we're trying to burn less fuel to solve the issue with the carbon dioxide. And often they are greenhouse gases. Okay, and if they are greenhouse gases, they're adding to that climate change, that global warming problem. So there's two problems with this one: waste fuel and their greenhouse gases. How do we reduce that? Well, it's hard to give kind of exact examples. So all we're going to say is that we need to ensure, again, ensure means make sure, ensure efficient. So that means not wasting anything, as little waste as we can. Ensure efficient burning or combustion, so that all the fuel is burnt, and that way there are no unburnt hydrocarbons to be released. So again, you can pause here, make sure you've written that down, all that down. And if I just zoom out quickly, we can look at this whole mind map. It's quite a big mind map with a lot of information on it. And it's probably quite small for you to see right now. But what I want you to do now is take a little bit of time to spend some time with your finger following around this table. Okay, so you need to follow along here, this line, up this line. Right, carbon dioxide is CO2. It's formed by the complete combustion of fuels. Carbon dioxide causes the problem is a problem because of greenhouse gas. It is a greenhouse gas which causes climate change. How would we reduce the amount of carbon dioxide? We'd have to reduce the use of fossil fuels. Carbon monoxide is formed by the incomplete combustion of fuels. The problem is that it's a toxic gas, and it's reduced by ensuring there's a good supply of oxygen. I want you to do that for all of these branches at least 3 times. So I want you to go around and do that for these branches 3 times. And then I want you to go back to the Google Slides where you'll find 5 or 6 questions that are based on this mind map. And I want you to try and do those questions without looking at the mind map. So once you've gone around 3 times, try and do the questions without looking back. When you think you've done the questions, go back to this mind map and check your answers, because all the answers to those questions are going to be on this mind map. Well done. Keep up the good work.